This video will explain the concepts of growth. There are several different ways of things growing. We are going to look at linear growth, exponential growth, and something called logistic growth. But there are other growth models that exist in the world. These are just the three that are the most common that we look at. So the first one is linear growth that we're going to deal with. And linear growth is where a quality can grow by a constant amount each time period. And what that means is that it's going to be adding or subtracting a certain amount each time period and not by multiplying anything. As an example, suppose we have a nuclear reactor that produces 1 unit of waste each month. Assume a storage facility already has 30 units of nuclear waste in it. You're going to send the waste each year to this nuclear power storage facility from your nuclear reactor. We want to create a model for this. So it looks like we're going to start with 30, so that's a good way to think of it as you're starting with 30 units of something, and you're going to be increasing by 1 unit each month. Since you want to know how much it also does in each year, we're going to change this month into years. So we do 1 unit per month, then you can do 12 units for every year. So that means you're going to have 12 units being put in for each year, and if t is our number of years, we can look at having where we start with 30, and then we're going to add that 12 times whatever the time period is each year. And this gives us our what we call a linear growth model. And what this model does is it allows us to see how we can predict how much there will be in other years. So if we actually want to be able to predict how much waste there will be in 1 year, we can just put 1 in for t and 1 in for t because these teams are in years. So we're going to put 1 in for t here and here because they're the same t. And you can go ahead and multiply together and you can find out, hey, this is going to be 42 units of waste after 1 year in the storage facility. Remember, we started with 30 already. Let's say you want to know how many in 5 years. So you can put 5 in everywhere you see t, and then you multiply everything together and do the arithmetic, and you get that there's 90 units in there for every year. So this is an example of using that model, but now let's actually see what the model is. So in general, the linear growth model is where you're going to have some function of time, and that function of time will be dependent on what time period you're in and a few other things. As we saw in our example model, we started with a certain amount. We're going to call that P0. P0 is how much you actually start with at time 0, and you decide what you want to be time 0. Time 0 could be a certain year. Time 0 could be what other way you want to start with, that would be where you start with. So it could be when you opened your business, it could be when you started putting things in the storage facility, whatever you want to call it. And then you're going to add in a certain amount every time period. So we're going to have adding in a d amount, d being that common difference, times t, where t is your time period. So P of t is the population after t time periods. P0 again is your initial population. T is your number of time periods, and D is that common difference. And we say that it's common difference because it's how much you're adding each year, so the difference between the 2 years is that D. So it's amount increasing or decreasing, because you can actually be getting smaller with a growth model. It doesn't seem like growth, but it is called a growth model even though it's getting smaller. So you can increase or decrease each time period. If you increase, D is positive. If you decrease, D is negative. So let's look at an example. This is actually a problem that's in the textbook we're using, and it's talking about how many people are living in a certain town. In 2012, there were 129,472 people living in that town. If we call time 2012 times 0, then we can actually just say this is our initial population. Granted, this town probably had people living before that, but this is what time we want to actually call that we're starting to count from. And it's decreasing by 2,600 people from 2012 to 2013. That just tells us that for each year, this is how much the difference in number of people. So our P0, we're going to again call 2012 our starting time. So our P0 is 129,472. Granted, again, people are living in this town before that, but this is just the time period we want to start with. Since we are decreasing by 2,600 people per year, D is negative 2,600 because we're getting smaller, D would be negative. And this looks like because we're decreasing by amount, this is a linear model. And looking at our linear growth model, we just have to take our linear growth model and write in the pieces. So we know P0, we know the D, we're going to put them in, and here's our model. And what our model allows us to do is, for a certain time period, predict what the P would be. So let's say we say for 10 years, 2022 would be 10 years. So if we want to find out what the population is in 2022, that's 10 years. Put 10 into this formula, and you can find out how many people actually will live there in 10 years. Notice it is getting smaller. We started with 129,000. We're now down to 103,000. Now let's say we want to do it in 50 years. So 50 years from 2012 would be 2062. So if you want to know how many people are living in this town in 2062, you know that that is 50 years. You put 50 years into this model. Again, I would always start with the model. Make sure you have the model in general, and then start plugging the numbers in. Don't just start plugging numbers in until you actually have that model written down. It makes life much easier on you. And if I put 50 in there, 50 years in there, I get a negative 528 people. Well, you can't have a negative number of people. It's just not possible. So somewhere close to the 50th year, we had everybody leave this town. So we really could say, if you get a negative answer here, there really are 0 people living there. So therefore, the town has actually become a ghost town. All right, that is the linear growth model. There are other models, but we're going to start with that one, and then we'll talk about the other models in the next video.